Yo, what's up guys? So today we'll be talking about logarithms, okay? So what I'm going to show you right now is how logarithms and exponents are related. So let's say we have the exponent a to the power of x is equal to b. How can I rewrite this in terms of logarithms? Well, I can write this as log base a, like tiny a, of b is equal to x. So these equations or statements right here are equivalent. Let's do some examples, okay? So let's say we have what is log 2 8, okay? So if you want, we can rewrite this. So remember, it's kind of base 2, and let's just set it equal to x, okay? So we have 2 to the power of x is equal to 8. So look, that's an easier way to look at it. It's basically asking the base to the power of what, to the power of x is what we're looking for, equals 8, okay? And we know that it must be equal to 3, okay? So now let's do, how about we do log 3, small 3, 27. Well, what's that equal to, okay? Well, we know that it's the base 3 to the power of the answer is equal to 27. So 3 to the power of what is equal to 27? And we know that that is 3, okay? And let's just do one more, okay? Let's say we have log 81 9, okay? Well, see, now our base is larger than this part right here, the 9. 81 is larger than 9. So we know it's going to be a fractional exponent, right? So 81 to the power of what is equal to 9? Well, we know that the square root of 81 is equal to 9. So log 81 9 is equal to 1/2, okay? And just one more just general thing. If you see log, like, I don't know, log 3, right? And there's no base, no tiny number, just assume that it means log 10, okay? Because that's how most standard calculators are. Now let's talk about graphing logarithms. So let's say we have the equation y is equal to b of x, okay? So this is an exponential function, and if I were to graph it like this, it may look something like that, okay? Like maybe something like that, okay? But let's turn this into a logarithm, okay? If we were to turn this equation into a logarithm, it says log of b y is equal to x. So notice something here is that the variables are flipped. So if we were to have a logarithmic function, right, and log b of x is equal to y, and we were to turn that into an exponent, it would say x is equal to b of y. So what that shows us is that when graphing with exponential functions and logarithms, logarithms are basically the inverse, okay? So let's just say we have another function, y is equal to log base b of x. It will look something like this. They'll have a sort of symmetry, as you can see here, straight down the middle, as they're inverses of each other. So you guys may or may not be aware of a constant called e. So e is found often when you are calculating with compound interest. So if we were to have the expression 1 plus 1 over n to the power of n, as n approaches infinity, as n gets closer and closer to infinity, right? This expression approaches the constant e, okay, which is about 2.71828. But like pi is an irrational number, so it goes on forever, okay? But there's a thing called a natural log, sometimes written as ln. And that is a special type of log. It is equal to log of x is equal to log base e of x. So this is using the natural log is very helpful when you having equations involving the constant e, because if we know anything, knowing logs, if we were to have log of, I don't know, log 3 of 3, we know that's equal to 1, right? So if we were to have a constant e and we wanted to cancel it out, we could do the natural log of e, which is equal to 1, because that's the equivalent of log base e of e, which is saying e to the power of what is equal to e, right? We know that's equal to 1. So now let's talk about the properties of logarithms. So let's start with the first one. So we have, just for example, we have log base x of a plus log base x of b is equal to log base x of a times b. So you guys should probably look up the proofs on your own, because I'm not going to prove them right here. Now let's talk about the next one. So if log xa plus log xb is equal to log xa times b, then log xa minus log xb is equal to log x a divided by b. And again, this is kind of the same rationale as with the exponential properties. So when you divide two exponents with the same base, or powers with the same basis, you just subtract the exponent. So because logarithms are kind of the inverse, when you subtract them, it's equivalent to dividing them. So now let's talk about when you have a logarithm. So how about we have log base x a to the b. When you have an exponent, then that is equal to that exponent times log x a. Okay? And I really suggest looking at proof videos, because I'm just kind of telling you right now what these properties are, but I think it's good to have a good understanding of why these work. And finally, this right here. So log a of b is equal to log xb divided by log xa. Okay? And this is very important because most calculators only have log base 10. So when you're working with bases that aren't 10, it's very convenient to be able to switch it to a log base 10 with this method right here. Okay, so now let's do a few examples, okay? And we should probably get out the calculators for some of these. So if we have log base 4, 5, what is that equal to? Well, as you guys know, on the calculators you can only really do, you can normally only do log base 10. So using our change of base properties, we can set this to log 10 of 5 divided by log 10 of 4, okay? And if we plug this into our calculator, I get log of 5 divided by log of 4, so you get approximately 1.61, okay? And feel free to work these out with me. Let's do another one, okay? How about we have 10, so this is going to be a different type of problem. 10 to the power of 3t minus 4 is equal to 6, okay? And remember how we were talking about how logarithms and exponents are related in some way. So let's turn this into a logarithmic equation so we can get the variable by itself. So remember, this would be the base. So we have log base 10 of 6 is equal to 3t minus 4. Okay, well then let's just isolate the variable. So we add 4. So we have log 10 6 plus 4. Let me just get that in parentheses. And now we're left with 3t. So we're going to divide by 3, and let's just bring it up here. Okay. So our answer is log base 10 of 6 plus 4 divided by 3 is equal to t. And because it's log base 10, you can just get out your calculator and solve this yourself. Okay. Now let's move on. How about we do 2 to the power of t minus 6 is equal to 6. So let's rewrite this as a logarithm. So log, oh that was a bad G, log base 2 6 is equal to t minus 6. And remember, our calculators are probably not going to be able to do log base 2. So let's do our change of base, and we can find that log base 2 of 6 is equivalent to log 10 of 6 divided by log 10 of 2. Okay? And that's equal to t minus 6. So we're going to isolate the variable, so we're going to add 6 to both sides. And we're left with log base 10 of 6 divided by log base 10 of 2 plus 6 is equal to t. And you guys can just evaluate that in your calculators. Now let's work with the constant e. And if you guys feel that I'm not explaining something fully or don't understand it, feel free to comment. I'm open to feedback, and I'd like to see what I can improve on. Okay, so now let's do the equation 1 is equal to 10 times e to the power of 0.4x. Okay, and let's try to evaluate x. So first we want to isolate the variable, right? So divide by 10 on both sides, so we get 1/10 is equal to e to the power of 0.4x. And what we can do here is that we can apply the natural log to both sides. So we can do the natural log of 1/10 is equal to the natural log of e to the power of 0.4x. And knowing our logarithmic properties, we can move the exponent to the outside. So 0.4x times the natural log of e. And what do we know the natural log of e is equal to? It's equal to 1. So we're left with the natural log of 1/10 is equal to 0.4x divide by 0.4 divided by 0.4, and we're left with the natural log of 1/10 divided by 0.4 is equal to x, and there's our answer. Hey guys, thanks for watching. So today we covered logarithms and how to work with them. I strongly suggest checking out Khan Academy, where they have more examples and the proofs of the logarithmic properties. Next video we'll be talking about the transformations of functions. So feel free to comment. Remember to subscribe if you like my content, and peace.